Thanks, Tony. And we'll go to the last speaker for today. It's Niels Kariil. To pronounce correctly, I don't know. Hope so. Are you there?
Yes, I'm there.
Yeah. Hi.
Hi.
Will you share your screen or should I do it?
I will try to see if I can share my screen here.
That would be great. Thanks. So yeah, he will tell us a little bit more about the products from Victron and how can they be integrated with small wind as well.
Can you see my screen?
Yes.
Okay, thank you. I will try to go here. Yes, one of the big problems you can say with windmills is that they are needing a grid to produce. If it not, it's a DC windmill, small windmill. But there is a way to do that, and I will today try to introduce Victron's products in use for windmills, so it can be off-grid. The first thing is that that's also very important together with solar, which is our really big market in this moment, is that the design is of course important. Calculation and is one of the places we see that people is missing a little bit. Installation is of course sometimes it's the coming people as don't know what they're doing when they're making the installation. And commission is, of course, as for a windmill, things you need to do to get the system running. The design is, you can say, in our world, when we are talking about solar, that is very similar with the windmills. Is of course to talk with the customer. Is it a new system, or is it a totally new system, or is it a part of an existing system? Is it a budget and all that kind of things? So it's really important to talk with the customer about what is they expect of the system and what do they have as a budget in the system. The next thing is, of course, the component selection. And our component will be the main component in the system to assist the windmill or the solar system to produce without going to the grid. It can also be a combination as a hybrid system where you can say you're both producing to batteries but also putting back to the grid. And it depends on what kind of output and input we have, what we are choosing of units. First of all, I will of course looking into battery voltage, and in the most of these cases, it will always be a 48-volt system. Battery in a system with solar or with a windmill will lead acid battery not be ideal. It will be a battery like a flow battery or lithium battery that will be the best choice on that, depending of course of which kind of use you have on the system. Also space and weight and all that kind of things can be a part of this, because of in some places the space is limited, which means that you cannot put in a huge battery bank, and again that will get you a choice for which kind of battery and which type of battery you're gonna need. AC output, you can say this is both for consumers, but it also for production. It can be a grid-connected inverter, as you see, or it can be a windmill that is on our AC output, which means that our system is acting as the grid will do, and both the grid inverter or the solar or the windmill is able to produce because they can see there's a network and there's correct frequency. So it can be a single phase, or it can be a three phase. It will be normal, or it can also be split phase if we are coming to US. Input is a little bit the same. Which kind of input do we have? Is it off-grid? It's the name says itself. There is no grid input to the system. It can also be, as we see a lot in Africa or in that area, that the grid is really bad, both in voltage but also in frequency, which mean that a normal grid inverter or windmill will not be able to work up to it. And there you can say you can use our system to make a stable grid, and the grid can come in when the grid is good enough to go into the system. A lot of times you have a generator connected to an off-grid system to as an emergency unit they're staying, and a lot of the times you're not using it only for emergency cases. You can see here we have a sheet that show more or less all that a complete system with all the parts that can be in the system, which mean on the AC input you could have a windmill, of course, but also a grid inverter. From solar you can have the genset, the grid. You can have DC input directly charging to the batteries. You can have AC output, of course, and you can also have DC output. And all these kind of things you want to monitoring and make a control, and that you can of course do with our products, both locally but also by the net. Sometimes it's easy to make a system when you are making a kind of, you can say, small diagram to what are we gonna choice of products, and so from that make a calculation and find the right parts to use in the system, and afterwards make a complete drawing if it for the system, so everybody know how it's made. Calculation, you can say on some parts is easy, but for a lot of people it's not so easy anyway. The first thing you're gonna need is to know how much consumption do we have, both in kilowatt, but also in kilowatt peak from the inverter, so you can be sure for the inverter system is big enough. Which means, so you have, as you can see with the number 2, that the inverter, we already have the calculation there. Next is there any grid or generator connected? The system must also be able to handle that. And as number 4, we need to calculate how big must the battery bank be to be able to serve the system that people is asking for. You can say, of course, loads AC, DC, when do they run? It's also important to know if people say, oh, I'm using 10 kilowatt hour per day, yeah, but is you using 10 kilowatt hour in a 4 hours period, or it's shared over the complete day or whatever it is. So you need to know when are the products running. Inverter calculation, as I say, number 2, so we can make the inverter calculation so we are sure for that the system is big enough to handle the loads that are coming and the peak loads. When I'm talking about peak load is if you are off-grid, you also a lot of the times have pumps, water pumps or whatever it is, and some of them is 3-phase pumps that is taking a lot of peak power when they're starting up, and you must be able to handle that also. So it's important to look into that also in the same time. Yeah, power consumption, it's easy because of if you want to also to take for a genset or from grid, you need to have a system that's supplying enough. And for the most important, one of the most important things and also the most expensive things in our system is the battery bank. So it must be clearly that the calculation of the battery bank is correct, because of else people is losing a lot of money on destroyed batteries, or they don't have the power the need or whatever it is. One of the things I'm facing and my colleagues is facing is people is calculating in amps and amp hours and watt and whatever it is, and we try to learn them calculate everything in watt peak and watt hours, and so everything will be easy to calculate. So it's always a matter to use the right terms when you are calculating the system. And I'm always by myself calculating everything in watts and kilowatt hour. Say, the first thing is, of course, important to make a list of which load there's on, and a lot of the times people is forgetting a lot of loads because of that is normal in the house. It can be a fridge or it can be a washing machine or whatever it is, because of it's just staying in the house. But it's important that at all that the loads that are coming is correctly calculated. And also that, of course, how long time do you need the products to run, and how many kilowatt hour do you need on the battery to run the products? Inverter calculation is quite easy because of depending on the temperature. It's always important to also look at the temperature, and because I'm selling a lot of products to UN and that kind of organization, is a lot of them going to Africa or other places where there can be high temperature. And it's important to calculate the inverter so it can handle the temperature. And of course, the sizing of the inverter so it can supply continuous, and it can handle if there's coming peak power. One of the things is that most of the time is the consumption in the system very low, but you have in the morning and evening, you always have some peak loads, and it's important that the normal loads can be supplied directly from the inverter, and you only have peak from small starts up that's bigger than the inverter is doing continuous. Power calculation is easy. It's just must be coming the same in as you are requesting out. But also in our system, you have the power assist, which means that if you have less power into the system, will our system be able to make power assistant and raise energy from the battery and add as parallel supply to the system, so it will be function even if you have less power into the system from grid. Battery calculation, it's that I was saying that it's one of the most important thing is to calculate that the battery is in the correct size, and you can say the battery size is calculated to, first of all, the standalone time, but it's also calculated to the consumption from the system, because of when you are calculated at system in watt or kilowatt, you must also count it back to the battery, so you can see that the battery can supply the amps when it's coming out, because we are talking sometimes about quite high amps from a battery. For a huge system, we're talking about up to 1,000 amps in DC, and it's you can say it's a heavy load. You must also look into is the battery system only staying as a backup system, or is a system you want to use in continuous, and it's a system that must be running for days without supply from solar or from windmill. One of the good things with our system is that you can supply it both with solar but also with the windmill, which means that the system always will get some power supply from one of them. You can say here there's a small calculation for battery bank. The customer is using 1,800 watt hour per day. We are here calculating in 12 volt. You can say have it been a 48 volt system, you can divide that with 4. But in a 12-volt system, this means also 150 amp hours. Are we talking about lead-acid batteries? Is normal discharge level around 50%, and you're not getting lower because of you will destroy the battery really fast if you're going down to heavy deep discharges. That means that the 150 amp hour will go to 300 amp hours instead, so you have the 50% level. Here the same, but you can say the customer want to be on the battery for at least 3 days. It's quite normal. People is asking for 3 days, 4 days, 5 days on battery to get the price for the battery, so they can use it, only have it for 24 hours or 48 hours on battery, and so they can start a genset or whatever it is. Battery charging. We really need to see which kind of chemistry we are using when we're talking charging, because if you are charging batteries with a genset because of there's no wind or no sun or whatever it is, it's too expensive to charge a lead-acid battery system because of the absorption period. They're starting with around 85% of the battery capacity. Will do that the amps is going down because of the internal resistance in the battery, and a genset will just be working at more or less at idle, and that is not quite good. In a solar system or a windmill system, you can say it's more or less doesn't matter if the sun is up for a long time enough to charge the battery and get the absorption period done also. And for the wind is not going down as the solar is, so you can say you are able to charge also in the nighttime. But in off-grid system, in a lot of the big off-grid system and the ESS system we are working with, is people using, of course, lithium batteries. But also the flow batteries is begin to come in because of they can really have a hard life. You can leave them uncharged for a long time, and so start the charge when the solar or the wind is coming back, and they will be charged up from 0 to full again, and they can handle that. Sizing for our products, all our data sheets is laying on our website, manuals, certificates, and what you need, so you can easily go in to see the product, what is it doing. And here if we say we can look at the small multiplus 12800, and we can see when we have a temperature of 40 degrees, it will only give 650 watt, and if we have 65 degrees, it will give 400 watt because of its derating because of the temperature. But if you use the data sheet and the manuals, you will get the most of the important things. Here we can see the temperature derating, and that is, of course, for nearly all electronic products that they don't like when it's hot. It's better when it's cold. So it doesn't matter what we are talking about. Fuses and that kind of things can also always be found in our manual when we are looking into our products. So you have the fuse size, and it's very easy to find on that way. Same with cabling. Cables is always staying in the manuals also, but we also have a small app that's free of charge. The toolkit app, where you can get down a cable calculator where you can calculate cable both on AC and DC side. There's also a lot of examples laying on our website below the products with the, you can say, kind of drawing. It's not a drawing. It's just showing the components and how they are connected, and also with the communication channel. Installation. One of the things we are facing really often is that people is just connecting the battery wrong, and the battery lifetime is gonna be really, really short. So here, you can say the four correct way to add batteries. And for lithium system is you normally always using bus bars. But when you are using lead acid batteries, people is often making normal strains, as you can see there. And then if you're doing on this way, the battery bank will have a longer lifetime than if you are making as people normally is doing, not diagonally, but only taking out in the end of the battery bank. And the lifetime on the battery will be really, really low. Bus bars, I can do that. You are getting the presentation afterwards. If you're not if you want it on a PDF, you can get it. But here is an example how you are doing the bus bars. Configuration. The most of our products today have built-in Bluetooth and is able to be programmed by a phone, a tablet, or a laptop, or whatever it is, and it's very easy today. For some of the products, it's still needed to put on a dongle and put it on a laptop, but these for that we call our V-Bus products, and there is a heavy programming you can do in that, so it's not made for the phone yet and for Bluetooth, but it will come in the future. Commission is, of course, first of all, run the system, see how it's acting, run with full load and all the peak loads that come in. Be sure that when you're starting up, especially for lithium batteries, that the batteries is fully charged, so the balancing in the system have been working, so all the batteries is balancing up. And so it's just, you can say, try it. When it's running, keep all the settings downloaded to a computer, so you have the settings. So if something is wrong, you always can take the settings from the computer and fill in if you're getting a new unit or whatever that's happening. Support. There's always support around in the world because we have sales manager in all areas. We have service centers in all, repair center in all countries. We have distributors with high skills that can help with both deliver the system, but also commission and if there's any problem with the system. We have a lot of, you can say, trainings if you want to know more about our products and how to use it. It's just go into Victron Professional. There's trainings in several languages, from English to Spanish, Portuguese, or whatever it is. So just go in and take the trainings. There's some of them is not for you can say windmill solar system, but the relevant trainings can be taken in there. All our system can, of course, also be monitored, and it's quite easy because of we have a homepage called VRM, and there you can put as many system in you want, and you can make as many accounts you want, and follow the system online. You can change setting in the system, you can update software. You can make homemade widgets and all that kind of things. And the best thing is to go into our homepage and log into the test site of VRM and see all the features we have. Just to show it, you can see here's a system that's sent by UN to Kazakhstan. It was sent down in a container where all the solar panels was in, the windmill was in, and the batteries, grid inverter, and MPPTs. We can also handle both MPPTs and grid inverter in the same system and a windmill. Taken out down at a farm in Kazakhstan, the windmill is set up and our units is making the grid. In the container, there's also placed a genset with built-in diesel tanks, so they have if something is going wrong. But up to now, it has been functioning without any problems. Also, just to show some few examples here, it's from Kathmandu in Nepal, where they are making that we call microgrids, and also there it can be possible to put in a windmill to also produce some power. Botswana, one of the places also is of course in Africa, and UN is making a lot of system also in Africa with our products. One of my own products is this container they're staying on Eastern Greenland, up from and is a plant that has been staying 18 from the North Pole down to the south end of Greenland. They have been staying 3 in this winter, and they are really happy with the system. And they have just put up a system also in Sagenberg. That's a research station close to Station North up in the North Greenland, northeast Greenland, and that is just put into to work, and it will with solar panels and gensets, and it's also really good function. Last slide from me, and I can see I was keeping the time.
Thank you.
Yeah. So it's up to you if there's anything more you want to ask about.
Just a moment, I'm trying to unmute.
Any question? I know that the system with the running Offgrid with windmill will be tested with our system up in Thy now, so you can get the experience from there.
We have a question here. Just a second, we're trying to unmute.
Sorry, it's difficult to hear what you're saying.
I don't know, I cannot unmute. Better now? Better now?
Oh, yeah, I can hear.
Yeah. We have some troubles with technical equipment here.
Okay.
There was a question, yeah, okay, you answered that. Not yet, that it will be too difficult in a lot of areas.
Yes, because of a lot of the areas where you are making, you can say, off-grid storage is in areas where you have no use of hydrogen.
Yeah, okay. And I also had a question concerning the training, the training options you have on the website. Is that free, or do you need to have a code from the product that you bought?
No. All our things is free. Also the training, and also on the Victron Professional is announced when there's training around. Especially you can say for a lot of people in Germany and Spain and Netherlands, it's also free of charge and free to join.
Mm-hmm. And the training part, is it just self-training, or is it with a certificate?
You can say it's on the website. It's a self-training with a questionnaire in the end, so you can see if you have understand it. And it's a combination of YouTube videos and sheets. The trainings, the physical trainings in Germany, they are making training also with hands-on, and that is done in a lot of places, and it's also able for me to make hands-on training.
Okay, thanks. Any other question from the audience?
Yes.
Yeah.
Regarding the life of the battery, are you considering to replace battery storage with hydrogen storage?
No, yeah, it said about that it's not applicable in many locations.
Yeah, not in this moment, but I cannot say what we are doing in the future.
What's the future? Battery is short life.
So I could see from your website that you have a lot of applications Offgrid, a lot of applications all over the world. So did you experience any issue with this huge temperature variation that you are working with? You're going from Greenland to desert pretty much.
No. It's a matter of that the system is correct calculated, and the system we have system. I have personally I've been working with system in northern part of Norway and the northern part of Greenland and on the North Pole, and we have never problem. And also in the northern part of Finland, Finland is our product used a lot in industry and in a kind of UPS system for the railroad. And you say it's working for minus 40 degrees.
Okay. And what about the hot climate on the other hand?
Yeah, you must of course calculate if the temperature is high in the area. Like I say, in the most countries in Africa, I'm always using the calculation for 65 degrees because of a lot of the times you will have around 40 degrees. And so it can fast be in a room where you have some big inverter system be 65 degrees.
Then do you have any cooling system, or you just I mentioned the system so that it fits?
Yeah, you can say UN have learned now that they're putting in an air-to-air pump as air condition, so they keep the temperature down because of also the batteries. It's hard to the batteries to work in that high temperatures. A battery system have the best temperature around 25 degrees as the electronic system has.
Yeah.
Any other question? Life of the battery. How long would this battery life?
You can say if it is it's lithium batteries, as it's sometimes will the lifetime be nearly the same. But if you take lead acid batteries, will the lifetime be a lot shorter when they are staying at so high temperature.
But you are not dealing with batteries as a company, right? You are just connecting the dots, or do you provide also battery solutions?
Yeah, we have batteries, but it's only because of we are not only working in the solar industry. We are working into the boat industry, ship industry, car vehicle market, and all that kind of thing. So we have both gel and AGM batteries and lithium batteries, but it's most for, you can say, for use in boats and that kind of things. For batteries to this kind of system, you will normally go to some of the suppliers, and we are working together with the most of the producers of flow batteries, lithium batteries, and that kind of things.
More questions from the audience? doesn't look like. But then, thank you very much for the presentation. And
You're welcome.
to all the speakers for the conference. Let's see if you can you hear me if I'm here? No, too low. Okay. So we will try to fix out these technical issues that appeared today, so that tomorrow we don't have them. We just didn't want to end up the webinar in the middle because the computer froze. So sorry for that. Hopefully it didn't affect too much the experience. And the plan now is that we will meet again tomorrow at 4 o'clock Central European summertime, and then we will go on more or less up to 8. And most of the presentations will be about markets and potentials for wind turbines in the different parts of the world. Big eye on the US. That's also where most of the speakers will come from. And then we'll have a couple of technical presentations which the speakers could not other days, so we just put them in there. And then finally we will conclude with a quite interesting presentation from Paul Guy, a quite famous author, that will make an overview of all the things you have seen around on social media as amazing new small wind solutions. So I really hope that you will be on board, because I think that will also bring in some discussion and spicy up the conversation. Otherwise, thank you a lot for today, and sorry again for the technical problems. Hopefully tomorrow we are fine with that. And I wish you all a good day.
Thanks for the good presentations, and hope to see you tomorrow.
Yes, see you tomorrow. Thanks.